Folks, this is a complete pack of SQL video, which covers maximum all the functions supporting SQL and predominantly Spark SQL. All the functions along with the technical logical explanation will be done in this particular video as a step-by-step process. All right. Now, I will go one after other. I'll start with very basic understanding. Then I'll go with the deeper understanding of every function. All right. Now, I have created a set of data sets which would solve all the problems here. Then we can take from that point. All right. Now, I'm going to use Eclipse and Spark SQL for this. So this is a document which I'm going to use. So I will start with very basics. I have 4 data sets here, right? I'm going to execute the whole SQL in my local Eclipse itself by reading the data and performing SQL operation in Eclipse. But however, these 4 data sets are mandatory. That's the reason in this document, I've kept all the necessary documents here. All right. So let me just take you through from very basics of this particular scenario. All right. Now, I have all these data sets. I put my Eclipse, took all the Spark imports, jars, and everything is ready. I'll be giving this whole code for you, no problem. So this particular SQL video will help you to execute everything in your console itself, in Eclipse console. Now, let's start reading the data first and create a temp views, because only after creating a temp views only we can start performing the SQL operations. And let's show the data for you. Yeah, 4 data frames are ready. See, very simple data frame, right? Now, let's take this as a data frame. All right. Now, I'm just taking this as a data frame as a beginning level. All right. We'll go one after other as a transformations. Then we'll go a bit deeper. All right. Now, all the data frames are ready right now with its respective temp views are also created. These are the 4 temp views I just created. Right. Now, let's start our first transformation. All right. Now, I have this raw data frames, ID, T date, amount, category, and product and spend by. I need to select only 2 columns out of it. All right. Now, how to do that? Definitely, I have to execute everything in the Spark SQL shell itself. Right. Now, have a check. Select ID, T date from DF. Very simple. I want to select only 2 columns from the data frame. You just have to give select. If you give star, all the columns will come. If you give select ID from T date from data frame, you'll see only 2 columns, ID and T date. See, only 2 columns are coming up, right? So this is one of the columns, one of the transformations we just come across, right? Simple. Now, let's go a step further. Now, as a second transformation, folks, everything is documented here. Don't worry, I'll be providing this document for you. I want to select only 2 columns. You will see everything as it full all the data. This is just 2 columns. Now, I want to filter this data frame where category equal to exercise. I want to filter this data frame where category equal to exercise. All right. Now I have a category. Now I have to filter this data frame in such a way where category equal to exercise. Right. Now how to start with? Now I have category of exercise only these columns. 1, 2, right? This one, 3. Only 3 rows has category equal to exercise. Have a check here. Only 3 rows has category equal to exercise actually. Only these, in this category equal to exercise, we have only 3 rows. Now how to perform that as a filter, right? Select star from DF. Select all the columns where category equal to exercise. Very simple. Where category is equal to exercise. First, the select star from tables will come. Then the filter has to get applied where category equal to exercise. Let's run it. Have a check here. We're just getting category equal to exercise. So you have to perform where category equal to exercise, right? This is single column filter where category equal to exercise. It's done. Now, let's go further. I want to filter this data frame where category equal to exercise and spend by is equal to cash. Spend by is equal to cash, but select only ID, T date, and category and spend by column. I don't need all the columns. I need to apply filter for sure. Category equal to exercise and spend by is equal to cash, but I need to select only 4 columns. Now, how to do that? Have a check here. Look at the SQL query now, right? Select star from DF. Not all the columns I need. I need only few columns, right? I need to select only 4 columns first. ID, T date, category, and spend by. I have to select 4 columns, ID, T date, category, and spend by, where category equal to exercise. Have a check. Category equal to exercise and spend by is equal to cash. Perform AND operator. And spend by is equal to cash. Very simple. Select ID, T date, category, spend by from DF. 4 columns I'm selecting from this data frame where category is equal to exercise and spend by is equal to cash. 2 column filter, right? Have a check here. In spend by and cash, I think only 1 or 2 rows I'll be getting. Category equal to cash on this one and this one. These 2 rows we have as a cash. See, only 4 rows has come up. That I have put down here. In the document, select columns, and I put category is equal to cash. Sorry. This is just a category equal to exercise. This is category equal to exercise and cash that I have documented. 2 column filter. Done. Next, removing this code. Now, in this data frame, in the first data frame, I need multi-value filter. I need in this category column, I need category equal to exercise as well as gymnastics. Now before it's 2 columns. This time it's a single column with two value filter. I need same column, but I need 2 values to get filtered. How to do that? We call it as in operator. We have to use in operator, right? What is actually the in operator is? Have a check, right? What is that? How many rows will come? Only category and exercise. I mean, category will exercise and gymnastics. 1, 2, 3, 4, 5, and 6 rows will come, right? only these rows has category equal to exercise or gymnastics, both exercise or gymnastics, right? So these 6 rows would come into picture. Now, let's see how to perform as. We have to use in operator. How to use in operator? Select star from DF where category in exercise and gymnastics. Now, what am I performing? Same column, select star. I'm selecting all the columns, right? I'm selecting all the columns, but I need category in. In operator will help you to put multi-values, exercise and gymnastics, so that you can able to filter with these 2 values. Run it now. Have a check now. Same column, but I'm applying 2 values to come up. See, category has only exercise and gymnastics, which we call it as in operator. In operator. That's what I have documented here. MultiValue filter. Category in this one. It's done. Now, this is also done. Now, I need to filter in such a way product contains gymnastics. What is actually the product contains gymnastics? Have a check here. In this product column, I have to filter in such a way product contains gymnastics. Now, how many products do we have contains gymnastics? Only these 2 rows has product contains gymnastics, right? Only these 2 rows has product contains gymnastics. Maybe I may have front and back of some gymnastics pro or something, but even though some prefix comes, even though some suffix comes, that doesn't matter. I have to filter this product in such a way that product contains gymnastics, right? How to do that? Product contains gymnastics, right? Contains in the sense I may have friend something like as gymnastics pro, Vivo Gymnastics Pro, Vivo Gymnastics Ride, whatever. In between, if I have gymnastics, I have to filter the rows which the product contains itself the gymnastics. How many rows comes out? 2 rows are expected. Now, we have to use like operator. We have something known as like operator. Select star from DF where product like, use percentile here as gymnastics. Select star from DF where product like, this percentile indicates whatever the prefix you have, whatever the suffix you have, if you have this word gymnastics, pick it up. That's what particular this particular code indicates. That means whatever the prefix or suffix we have, if you have something in the gymnastics, right, please pick it up and filter the data. Now have a check. You'll get those 2 rows which has product contains gymnastics. See, this is what I have documented here as well. Like filter, product contains gymnastics, right? Like filter. Now, next filter. Now, I want category not equals to exercise. That means I don't want exercise. As in, so far we filtered the positive scenario, no negative scenario. In this category, I don't want exercise. Except exercise, pick everything. That means not equals to exercise. Category not equals to exercise. I don't want exercise. I need all the other things. We have to use not operator. How to use not operator? Select star from DF where category not equals to exercise. Exclamatory symbol indicates not. Category not equals to exercise. I don't want exercise, folks. That's what this exclamatory indicates. Not equals actually, right? That indicates not equals. So that category in this column, category not equals to exercise. You will get all the rows, but will not have category equal to exercise. See, you will not see exercise. Exercise band is different. Don't worry. This is no exercise at all. So that we call it as a not operator, right? That's what I have performed, not filters. Category not equal to exercise. Complete this one. Okay, done. Next one. I want to perform multiple columns. Like, for example, have a check. Category not equals to exercise and gymnastics. Before we used to have not equals to only one value. Right now, it is multi-value. Except exercise and gymnastics, pick it up. Except, I mean, exercise and gymnastics, what I have, this row will be, this row would come. This row would come. All these rows would come. Sorry, gymnastics will not come. Team sports will come. This team sports will come. 3 rows will come because these are the only 3 rows which has category not equals to gymnastics or exercise. Only these 3 rows, right? Only these 3 rows has that particular accessibility. Category not equals to exercise or gymnastics. Now, what we have to perform? We have to perform where category not in, always not in. In represents, you can give multi-values. Check on this. Now, category not in, multi-values here. See, with 3 rows has come out. This is not in, category not in. That's what I have filtered in this diagram. Not filters, category not in exercise or gymnastics. Perform this. Next, putting it back. Now let's take the raw data frame, okay? Now let's take the raw data frame. Now, let's go a step further. Now in this raw data frame, I need null values, null filters. See, product has some nulls. These rows, nulls. Only these 2 rows has nulls in product. I need product is null. Product is null. Is null rows. Only 2 rows has product nulls. How to execute that? Have a check. Have a check. Spark.sql. Select star from df where product is null. That's it. I just need only the null values, null rows. Select star from df where product is null. Okay, give me is null. Okay, only the null values I'm expecting from this product column. Have a check now. Only null rows will come out. See? Only the null rows. What if I do not want nulls? Not null. I want the rows with not nulls. Right? I need product not nulls. Just perform is not null. That's it. Product is not null. Check out. You'll not, other than the null, the other rows will come into picture. See, no nulls at all in the product. It filtered not nulls. This is a raw data frame, but filtered not nulls. No more nulls. This is not filters. That's it. I have documented that also. This is null filter. Not nulls filter I should have not put. You can add if you require. All right. If not, I can add it here. Fine. Filters are done. Let's move further. All right. Now, I have this raw data frame. I need max of ID. If you see in this ID column, let's consider this ID column. What is a maximum number we have? 8. So I need max of ID. How to know the max of ID from this data frame? Have a check. Spark.sql perform select max of ID from DF. That's it. If you want to rename, you can rename if required, or else not required. It's up to you. Now check. I'm selecting select max of ID from this data frame. You'll get that max of ID. See? If you want to alias this name or rename this, you can mix it. ID max. I want to rename this as ID max. Have a check. See? Same applies for min also. That means what is the minimum on this particular ID? 0 is the minimum value. In this particular ID, 0 is the minimum value, right? So if you want to perform min, you can perform min here. That's what I have documented here. Max function 8 will come, min function 0 will come. Please perform this. If I want to know the number of rows count, what is a count? Totally, I have 9 rows as a count, right? 9 rows, I have it as a count. How to get the count? Very simple. Now, select count of 1 from DF. Count of 1 from DF. Now, it will give you the total row count. Have a check. These are the total row count. Simple, right? You can perform this operation but just doing a count of 1 from DF. What 1 will do is, it will place 1, 1, 1, 1 for each row, actually. And it will count the number of, instead of concentrating on all the rows, it will simply make 1, 1, 1, 1, 1, 1 for all the rows. It will take the count of these rows. That's it. Simple. It is quite simple. The same can be performed using count of star also, but comparatively count of 1 is of high performance. This is a count. Now, this is the count. Now, that is what I have mentioned here. Next, I want to have an extra row at the right. Imagine. As status, which we used to saw in DSL also. As status, as an extra column, what I should have in this status? I should have, for cash, I need 1. Just like that. Like, depending on the spend by column, cash, for credit, I need 0. For cash, I need 1. Credit, I need 0. Cash, I need 1. 1, 0, 1, 1. Like this, I'm expecting the data. Depending on the spend by data, I'm expecting status column in the last. If it is a spend by cash, it is 1. If it is spend by credit, it is 0. We call it as a conditional statement. I need to use it as a conditional statement, right? Condition. Okay. If this is a condition, do this. If that is a condition, do that. That's a conditional statement. How to perform that? We use it as a case when statement, right? What is actually case when? Look at the code now. Select star, comma, case when spend by is equal to cash. Then 1. Else 0. End. Simple. Look at this SQL query. Select star, case when spend by is equal to cash, then 1, else 0. And now run it. Very simple, folks. It's a simple English. Case when spend by is equal to cash, then 1, else 0. End. Have a check now. Sorry. Spelling mistake. Okay. Okay, one sec. Sorry. From DF. Forgot to give DF, right? From DF. See it then? You got cash 1, credit 0, cash 1, credit 0, cash 1, cash 1, like that. But the column name is not well. I need it as a status. Then what you have to do at the end, make it as status. After case when condition, put it as status. Have a check. That's it. Done. If you have multiple conditions, it's just 2 conditions, right? Case when this is cash 1, if it is a credit 0, L 0, that's it. If you have multiple conditions, like if you got Paytm, right? For cash, it is 1. For Paytm, it is not available, L 0. Like I have 3 conditions. If I got any extra column other than cash and credit, any extra I got, you have to put multiple whens. Case when spend by is equal to cash, then 1. When spend by is equal to Paytm, then NA, like that. L 0. Multiple when condition. Case when spend by is equal to cash, then 1. If it is cash 1. When spend by is equal to Paytm, then not available. L 0. I mean, I have only credit or some other L 0. End. That's it. You can perform like that as a multiple conditional statement. Right? This is the conditional statement. This I have documented at the bottom. Please practice this. All right. Now, this is a statement. Now, next what we are going to see, concat 2 columns. What is actually the concat 2 columns? It's pretty simple. Have a check. Concat 2 columns. I have ID. I have category. For example, 0 exercise, 1 gymnastics. I have data like this. Imagine I want an extra column known as con data, which should have, right, concatenated result, 0 exercise, like this, with a hyphen delimiter. I need data like this, right? 1 gymnastics. I need a concatenated data for this, actually. I need one column, but this has to get concatenated together. We call it as a concat. What is how to perform this in SQL? Very simple. Have a check. Select, just select only few columns. 2 columns I'm taking, which I need actually. Then concat ID -1 hyphen category. Simple. I'm putting 3 columns here. ID, comma category, concat of ID hyphen of category. So first ID column will be picked out, then it perform the category column. So first column will be picked up, then hyphen, then the second column. Have a check now. Oh, sorry. I didn't give the table name. Sorry. See the result, folks? It got concatenated. 0 hyphen exercise, 1 hyphen exercise band, 2 hyphen exercise. See, these 2 columns got concatenated, but the column is not good. So you have to alias it if required as con data. See, this we call it as a concatenate data. That's what I have put it here. Concat data. See? Now, next, another important information here is, if I want to concat multiple columns, right? I have to concatenate multiple columns, ID category. What I'll do, I can perform like that. Comma product. I need to concat 3 columns, ID, category, and product. You need not to give all this, but it will do automatically. Concat of ID, comma, hyphen, product. You can give like that. 3 columns concatenation, actually, right? ID, hyphen, category, hyphen, product. 3 columns are getting concatenated here. See, 3 columns are getting concatenated. 0 hyphen, exercise hyphen, gymnastics. But if I have multiple columns like that, how many times you give hyphens like that? Hey, ID, hyphen category, hyphen product, hyphen spend by, like that. It's very hard for us to give that many times. If you are going to concat multiple columns, don't use concat. Use concat WS. What you can do in WS is, you can first give a delimiter. That's it. Then give ID, category, product, right? You need not to give ID hyphen category hyphen product. No required. Just give the delimiter here. Give all the other columns here. Obviously, concat WS can take care of all that. Check. Say same result, but I achieved this in concat WS. Because only once you mention the delimiter, all the other columns automatically gets concatenated. That's what I have done here. See, concat WS here. If you want, I can give you this query. That's it. So far, we have come across all these folks. I'm going a bit deeper now. Concat WS is done. Then lowercase data. I have a column, right? This is done. Now lowercase the data. Lowercase in the sense uppercase and lowercase, small letters. Lowercase. I want to lowercase this whole category into a lowercase. Spark.sql. Category. Select star from. Select category. Sorry. Right? Then lower of category. Lower of category. Simple function, lower function. I'm selecting a category column and lower function as lower from df dot show. Have a check. First, I'm selecting the category column as well as the lower of category column. Check. Lower. See? Exercise E is caps, but it has done the lower. All the values will be lower. Same applies for upper also. Imagine if it is upper. I need all the columns to be upper, all the values to be upper. Upper function. Simple upper function. See, all the values got upper. That's what I have done it here. Lowercase data, uppercase data. Okay, if I not done the upper, that's okay. You can perform upper, not a problem. Now, let's get into the next one. Seal operation. Seal operation. What is known as the seal? See the amount column. I want to round it off. Not exactly the round. There is a difference between seal and round, right? What is actually the seal mean? All right. Seal represents rounding of a value with upper value, rounding off with the upper value. That's a right statement. Seal refers to rounding off to the upper value. What is that? For example, I have 300.4. What is the upper round value? 301. For 300, what is up 301? Like that, it will seal the data. Have a check. It will make it seal. Amount. Seal of amount as seal. Check. Select amount. Seal of amount as seal. Seal in the sense, round it to the upper value. See, it got sealed. Right? Upper value. But we have round also. Round function. Round. What round will do? Nearest integer value. See, for 300, the nearest 300.4, the nearest is 300. If it is crosses 5 or greater than 5, then it reaches to 301. Seal abruptly makes 1 plus. If 300.4, 301. But round will do, if it is 304, okay, what is nearest one? Okay, 300. It will round it to the nearest integer. That's the difference between seal and round. See, I don't have any dot fives. If a dot 5, that will add 1. For 4, the nearest is 300. That's how it will round the data. That's how I have performed the seal operation. And I forgot to mention the value here. That's okay. Renaming the value as round. So this is a round value result. That's okay. Now replace nulls. How to replace the null? What is actually the null replacement? Now, in product, I have some of the values known as null. Null. Right? I have null. What is actually the null mean? Right? Now, null is nothing but no value. Now I have to replace it, this particular null value with NA, right? I want to replace this null here with NA value, NA. How to do that? We have to use coalesce function. Select, I'm just selecting only one column, product column, okay? Because product is only person who is undergoing the transformation. You can perform all, you can open all the columns, not a problem. Then coalesce of product with NA as null rep. I'm just giving the name as null rep. See, coalesce will take the product. If it has any nulls, it will replace it with NA. Have a check here. I'll paste this in the command line. See, nulls got replaced. Coalesce will help you to replace the nulls. Okay. Pasting the value. Done. That's your replace nulls. That's the that's what I have documented here. Now trim the space. What does actually that space mean? See, if I have gymnastics, if I have any empty spaces, front and back, imagine I have some empty spaces, front and back of a string in a row. By using trim off category of that column, for all the values, it will remove that empty spaces. It will remove that empty spaces. So that none of the empty spaces we have. Unfortunately, the data which I provided you do not have any empty spaces front and back. It will not remove the in-between space. No, only front and back space will be removed if we have any. If you want to perform, you can perform trim operation if required. Trim off product. But I do not have it, but still, I thought of telling you trim the space, right? But I do not have any spaces to remove actually. Yeah, that's trim the space. The next one is distinct. What is actually the distinct mean? Distinct mean nothing but taking the unique values, correct? Now, I have category. How many unique values of category do we have? Exercise, I have three times. Gymnastics, I have three times. Team sports, I have two times. Like that, I need to have the distinct column values. Select distinct of category. Imagine from DF. I just want distinct of category values. See, only four distinct values we have. Unique values. You can also perform distinct on multiple columns. Like you can perform on multiple columns with distinct spend by. Now, both the rows will be taken into account. Like, okay, how many exercise and cash we have? Like it will do this kind of operation. Have a check. Leave the product aside. Two columns. How many distinct and product we have? Exercise and cash we have. One, two, that's it. Only once this data will come. Excise and band credit, I have only once. Excise and cash already took. Gymnastics and credit, only once we have. Team sports and cash, two times we have, but it'll take only one. Excise and credit, only once we have. Gymnastics and cash, only once we have. Team sports and credit, cash, it's already have, no problem. Gymnastics and cash already have. Only 6 rows will come out because these are the only distinct rows we have. See, only 6 rows. distinct on multiple columns. Simple. This is quick data on values. This is distinct, which I have documented here, right? Now, substring. It's quite important. All right. What does actually substring mean? Let's get back to raw data. Substring. See, one second. Let's take the raw data frame. Now what I have to perform, I want to perform a substring on product column. I need only first 10 characters. Only 1 to 10 characters I want in this column. Only 1 to 10 columns I need in this column. Starting from gymnastics, starting from G, I need 10 characters. Starting from W, I need 10 characters. That's it. I don't want anything else. From gymnastics, only 10. Like that, I need, starting from the first character, I need 10 characters. Starting from first character, I need 10 characters. How to perform that substring? Check. Select substring of product 1, 10. That's it. As sub, I'm just giving this as a value. I'm just selecting substring of product 1, 10. From the first character, take 10 characters. That's what I'm just giving up here. See, it took a product column. From first character, it took 10 characters. From first character, it took 10 characters. From first character, it took 10. Like that, it has took. If you want to select the cutting, that string from second character or third character, change that. Substring of product, start from the second character, start from the third character. Like that, you can perform the substring here. I'm putting up here. All right. Now, substring with split operation. Right? What is actually the split operation mean? Now, did you see space here? I mean, I want to do a split operation here. Right? I'm taking this value. I want to perform a split of this column, product column, split it with space. Split it with space and take the 0th index. Why I call it as the 0th index? When I split this with space, when I split it with space, right, it will split with spaces splits separately. Then that becomes 0th index and first index. If I split a product column, for every space, it would split and we can select the respective index value. Okay, I need to pick only the first split out of it. But unfortunately, we have only one value here. Let's see how the split works. All the other values, I do not have any space splits. Any delimiter. You can put any delimiter in this gap. Here the delimiter is space, but in this gap you can put any delimiter if you want. Okay. Now have a check. I'm performing the Spark SQL now. Select product, comma, split of product with space, select 0th index as a split. Simple. Split of product with space, take the 0th index as split. And that's it. Have a check now. Have a check. Right? See, the split has happened. It took only the first split. This only row I have as an example. All the rows I do not have spaces. When there is nothing to split, it will take always the full row. This is a best example. Gymnastic Space Pro, it split with space and took the first element of that split. This you can have it as an example. Instead of using substring index, I suggest to go with split. Split is easy to understand and easy to execute. Yeah. Next. Union all. Now, next topic is union all. Right? What is actually the union all mean? Now I have two data frames, right? I have two data frames. Let's take the second data frame now into consideration. Let's see two data frames first. This is the second data frame. This is your first data frame. I want to union both the data frames. What is actually the union mean? Imagine I have two data frames, right? And I have other data frame. Union is nothing but I have to club these two data frames. Why I call it as clubbing is one after other data frame I have to place like this. This I call it as a union. These are two data frames. I'm unioning it. Union. But there is a difference in union all. What is actually the union all? Let me perform union all now. Like I have two data frames, right? I have a check. Now I can replace the data frame. Spark.sql, select star from df, union all, select star from df1. Sorry, df1. Sorry, select star from df, union all, select star from df1. Have a check now. Both the data frames will come after the union. See, this is my first data frame, 0 to 8. This is my second data frame, 4 to 7. First, have a check, ordering, 0 to 8. This is the first data frame. This is from second data frame. Just union. Union is combining two data frames vertically. But there is one issue here. Is it not these two from the fourth row of mine? Fourth ID of the first row and the first data frame, fourth ID of the second data frames are same. Have a check. The fourth row of the first data frame and fourth ID of the second data frame, both are same. During the union, I want to eliminate these duplicates. How to do that? I want to do union for sure, but any duplicates are coming up, I want to remove it. I don't want that. But union all cannot do that. Union all directly take the first data frame Directly patch the second data frame at the bottom. But union will do that. Instead of union all, if you put union, it will automatically remove the duplicates if it found anything during the union. Have a check. See, fourth came only once. Don't worry about the 7. See, for 7, it's not duplicated. Two IDs with 7, but I have a different other columns. But 4 is a duplicate one. So only 1 4 I got, other 4 got removed. That's the difference between union and union all. Union all straight away do the union between two data frames. Union will do the union, but in case of any duplicates it found, it will remove during the union. So this is what I have documented here. Union all and union, right? See, this I have performed. Next, going a bit deeper, it's time for aggregations. So concentrate, please. Now, out of this data frame, I want to find total amount collected for each category. See the requirement. Find the total amount for each category. That means I have exercise 300, again exercise 300, again exercise 100. Approximately it would be 700.8. I need that aggregation total. Okay, what is the total for exercise? Now, what I mean to say is very simple. What is actually aggregation mean? Just a simple example. If Sai has 4, Zayo is 6, Sai is 3, Zayo is 1. If I say how much Sai has collected means, you'll say Sai got 8, Zayo got 7. How we are doing it? Now you're just grouping this name column and adding 5 plus 3. You're just grouping this names and adding 6 plus 1. That's how you got this result. Same applies for this also. That's how they're asking. Hey, what is the total amount that exercise has collected? Group all the category columns. Find 300 plus 300, 300.4 plus 100. You'll get the total for exercise. Similarly for gymnastics, similarly for all the other categories. So I have to perform group by operation and sum of every amount. Now have a check how that gets performed. Check. Now I need select sum of amount as sum. See the sum of amount. Okay, I'll take category also. Select category sum of amount as sum from DF group by category. I'm grouping the category column and finding the sum of amount. I'm grouping the category column and taking sum of amount. Have a check. Have a check. Gymnastics. Totally 500, isn't it? Gymnastics 100. Gymnastics 200. 200. See? 100. 200 plus 200. 500. You got. Team sports. 300 plus 300. 600. Exercise 300.4, 300.4, and 100. 700.8. Exercise band, only one we have, 200. That's what we call it as an aggregate. grouping a column, and finding the sum of other column. Now, how to aggregate on two columns? That's important, right? See, same applies for this also. Have a check. Sai Chennai, Sai Hyderabad, Sai Chennai, Sai Hyderabad. For example, right? 8, 9, or 8, 1. Chennai, 2. Hyderabad, 7. Now, my question, like this is a column names, right? Name, city, amount. Correct? Now, how much Sai collected in Chennai? Two columns aggregation, 10. How much Sai collected in Hyderabad? Right? Sai collected in Hyderabad is 8. Now, two columns are undergoing the aggregation and finding its respective sum. Two columns. Name and city is going group by finding the sum. Two columns. Similarly, in this case, find the total amount spent on category and spent by. Okay. How much exercise and fitness, I mean, remove this product for a while. Okay. Consider this as a one guy. Right? This for a while. How much exercise and cash, like for both category and spend by, what is the amount spent? So exercise and cash, these gets grouped by. Adds 300 plus 300. This will not come because this exercise and credit. Two columns I'm grouping now. Gymnastics and cash. This gets grouped because it's a cash, right? Gymnastics and group. This gets added like that. Two columns aggregation. How to perform two columns aggregation? Have a check. Same. Select category, product, or category spent by, sum of amount, group by category, comma, spent by. Two columns I'm performing. Category spent by, sum of amount as sum. Have a check. See? Gymnastics and cash, totally 400. Check. Gymnastics and cash. This is one. And these two rows comes under gymnastics cash, which is 400. Two columns aggregation. Exercise and cash 600. Let's see. This is exercise cash. This is exercise cash, which is 600.8. That's what come down. Excess and credit, because this is a different row. Because I cannot combine with the before one because this is different. Exercise and credit is different. 100. You got that 100. Like that, two columns aggregation we can perform. This is another aggregation. See the code level. Select category, spend by and sum, right? Where as sum from DF group by category, comma, spend by. That's what I have documented here. This is a single column. This is multi-column. Total, you'll get it. Please perform this. Now, I need the count also. See, I definitely know. See, this is a total sum of this value. Okay, you tell me. I'll ask you one question. Tell me How many gymnastics and cash we have? Okay, it got added. Okay. Gymnastic cash has 400. Gymnastics cash 1 and 2. How many gymnastics and cash do we have? 2 rows we have. That's the reason it got added as 200 and 200. We got 400. But I need how many got counted? Okay. 2 came into this picture. I need this 2. Okay. 2 is there, exist in this. I have 2 here. I need the sum for sure, but I also need the count. How many amounts has counted? 2 amounts combined to form 400 of excess gymnastics and cash. What about exercise and cash? Exercise and cash again has 2 rows. Only these 2. No other exercise and cash. I need that count as 2 here. That's what I'm expecting. What about exercise and credit? I think exercise and credit is only 1. Only this one is exercise and credit. I need the count here. Very simple. I need one extra column. Category as spent by, sum is done. Just count the amount. Okay, I need the count also as a count of amount as C and D. That's it. At the end, it will provide you the counts as well. Have a check. See, the count has come up. This is the total count, right? This is where we can have a count function as well. This is what I have documented here as well. Count, right? Done. See, here I'm grouping up category and spend by taking the total as well as the count. How many counts of amounts we have? This you can perform. Now comes the next requirement. What is max of every category? What is the max amount of every category? I need not the sum. This is just a max amount. For every category, what is the max amount for each category? Okay, for exercise, which is a maximum one? This is the maximum one. 304. Compared to both of them, 304 is the maximum. Similarly, what is the maximum for team sports? Okay, team sports I have here and here. Maximum is going to be 300. What about gymnastics? But gymnastics, 200 and 200. Seems I've repeated the day. Okay, 100 I have. But what is the maximum? 200. We can find min and max for that for every category. Like how to do that? Very simple. Same aggregation. It's going to perform the aggregation the same. Select category, max of amount as max from DF, where, sorry, group by, right? Group by category. Have a check. So I'm just taking the category, max of amount, group by category. So all the categories get grouped. Okay, gymnastic gets grouped, exercise gets grouped, and it take the max value out of it. That's the result. Have a check here. See, this is a max value for every category. Same applies for min also, and I have documented that as well. And if you want to do an order, like you want to do an order, G7, T20, E5 exercise. I want to order this category. It's pretty simple. Put an order by at the end. Like perform the group by, no worries. Here, put the order by so that it will order with the alphabetical order. Have a check. Order by category. See, EX, exercise E5, E5, G7, T20. Like that, it got ordered by ascending. By default, it's ascending. If it's a descending, you have to make category descending. It's a descending. So accordingly, it will add. That's what I have put it as a order by. Now starts the actual window operations. All right. Window operations are really the very important topic. So kindly consider. We are going to go very deeper with Windows operations. All right. Have a check. What is actually a window mean? Window is nothing but a section of data. All right. Now, what does actually the windowing mean? Each almost it's similar to group by that we call it as a window. If I have category like exercise or E, C, E, F, C, E, F, like that. What is actually the window? Window is nothing but I'll segregate all the E's separately, then F separately, then C separately. This I call it as a window. See, windowing, okay. Perform operations for separate each categories as a window. Got it right? Window by category column. So it will get a window. Later on, I can perform whatever be the transformation I want. I can perform on for each one separately, like whatever the information I want. But window is nothing but a categorizing a column, right? Window is nothing but a categorizing a column. Now, how that works, how we start, that we'll discuss a bit deeper now. All right. Now, let's imagine we have a concept of, right? In this case, what is actually the window mean? Have a check. Row number, right? Row number is nothing but an incremental number. Okay, let me take it this way. All right. Imagine I have a category and an amount. All right. For see, this is a category and the respective amount. What is actually the amount mean is I have to rank or create incremental row number for every category of in the column. Now imagine the row number starts like that: 1, 2, 3, 1, 2, 1, 2, 3, 1. Closely watch out this data. You will see something very interesting. Uh, Finding the right font. Check here. Check this guy separately. Check this guy separately. Check this guy separately. And the below guy. What happened? What did you understand? Concentrate. Concentrate. All right. Now, for every gymnastics, I put a row number in the descending 1, 2, 3. For every team sports, I put descending 1, 2. Descending 1, 2, 3. Exercise band 1. So I want to create such a kind of a column. Ranking or row incremental row number should happen in the category wise. We call this as a window function. All right. Category guys, windowing the data. Okay. Gymnastics are separate. Team sports are separate. Exercise is separate. Exercise band is separate. Right. Now, how to validate this query? Concentrate on this query a bit. Select category amount. This is for sure. But create a row number over partition by category. Partition by category is nothing but I'm sectioning with every category. Okay, did you see? Gymnastics got categorized. Team sport got categorized. Row number created for every category separately. Order by amount descending. So what am I doing? First, for every amount in the descending order, create incremental row number. See, the incremental row numbers got created for every for for gymnastics. It created separately. Have a check. The row number got created. Gymnastics, it created separately. For team sport, it created separately. For exercise, we created separately. Right? Now 1, 2, 3, 1, 2, 1, 2, 3, 1. So that's the reason we call it as a row number. So this is a function which it creates a incremental row number. Have a check. Have a check. Category amount, row number. 2. What I have to create? Partition by category. Section the category. Order by amount descending. So for every descending amount, this how it will help you to create a second highest salary in Spark also. Actually, right? See, the ranking, the row number happened. This is gymnastics row number. This is team sports row number. This is exercise row number. And this is exercise band. Done. This is a row number. Similarly, you can use rank also. Rank. What is actually a rank? What's the difference between rank and row number? Row number is predominantly straight away it puts 1, 2, 3, 1, 2, 3, 1, 2, 3. But rank, when the same value comes into picture, right? Rank means both are in the same rank. Correct? If it got to rank both, it will give the ranking same for both of them. Have a check. 112. If I have 300.4, 300.4 as a same number, it will put the same rank 1, 1. Then the other values would be 2. That's what should have happened here. Sorry. This is dense rank. No. This is dense rank. Sorry. Dense rank. Dense rank. Sorry. That's what dense rank. That's a difference in rank. I'll tell you what. A small difference between rank and dense rank. I'll tell you. Dense rank will directly put whichever the common values we got, it will directly give the same rank for every data. See, it plays the same rank. Check the exercise. Since it has the same amount, for every partition data, it ranked. This is dense rank. But what is rank? There is one slight difference between rank and dense rank, right? See, 304, 300.4 is the first rank, 100 is the second rank. But in dense rank, if it got the same values, it will rank 1, 1. But it will create 3 for the second highest, or the next highest one. The reason, it will consider these two are ranked separately. These two are ranked separately. Then in case of dense rank, it will be 2. But since I already ranked 2 people, it will make it 3. When rank and dense rank plays a big role when I got the similar amount aggregate value. Definitely I have to rank. For every amount, I have to rank. But that's what happened here. Have a check here. 113. Row number is straightforward. See, even though it is same value, doesn't matter. It will descending and put a 1, 2, 3. But for dense rank, it will create 1, 1, 2. But for rank, it create 1, 1, 3. But see the code very clearly. Category amount, okay, these two columns. But rank, partition by category. For every category of data, order by amount descending. Then start your ranking. That's what rank, dense rank, everything. Right? This is how you can also find the second highest salary using a rank and dense rank, predominantly dense rank. Now, another windowing function, lead and lag. All right, I'll tell you what is actually the lead and lag mean. Take this data frame a bit. All right, take this data frame a bit. Now, this is lead, okay? Have a check. Now I need an extra column known as lead as an extra column. And I want to lead the data. Have a check. This 200 should come here. This 100 should come. For every category, this should happen. Imagine what is actually the lead mean is that will create in such a way. This is 200.0. This is 100.0. This is null. Concentrate this very closer, right? Lead is nothing but for every category of, for every individual category, the lead will happen, right? Leading 200 goes here, 100 goes here. This is null. This kind of a lead function will help you to compare the below data. I'll sort it out, and then if you to find a differentiation, consecutive data differentiation, I'll create a lead function and I can perform differentiation if required. 200 minus 200, 200 minus 100. Okay, this employee to this employee, this is a difference. You can perform any operation, but lead will help you to lead the data from here to here. Have a check, right? This becomes null because that doesn't have anything. What happens to lead in team sports? Lead will come here, right? 300 will come here and it would be null. The below would be null. Same applies for here. Leads will happen like 300.4. This is 100.0. Null. So leads will happen to do the comparison. Okay. And this is obviously this is going to be null. Have a check. That's what should have happened here. Lead function. See the code. Category amount, lead of amount over partition by category. For every category section it, order by amount descending. So this is your lead function. Have a check. This is your lead function. Lead is nothing but lead the column in the right. Category amount, lead the amount over partition by category, order by amount descending. Have a check. See, lead happened. See the value 200 to 200, 100 to 100. Nothing to null. That's it. This is one data. Done. 300. That's it. Team sports is done. That's it. 300.400, 100.100. This is done. And this is a lead function. Similarly, we have lag also. What is lag? It will put down. Lead is up, one shift up, right? But this is lag. Lag means one step down. All the data will come down, like 200 to 200. For every category, see the lag. See the lag. 200 to 200, 200 to 200. This will be obviously null. 100 will not go anywhere because it's a lag. 300 to 300, right? Then 304 to exercise, 304 to 304, 304.4 to 300.4. This is for exercise. Lag will put down, lag down, right? Same applies for lag also. Lag operation, right? Lag will put one step down. Folks, lead and lag comes under functions again. Have a check on this. Yeah. Then we have having and joins, folks, the last topic. Please have a check. This is lag. See, the data has come down, down. Team sports, we do not have anything. So exercise down. That's what we call as lag. This will help you for the differentiation between two records. Now I can find differentiation between first and second guy, ranking people. Lag would help you, right? That's what lag function is. Then having function. See, predominantly having will help you to find the duplicates, not find the duplicates. How many times a value got duplicated? Having function will tell you how many times a row got duplicated. That will help you, right? Look at this code. Look at this code very closer, please. Yes, if you see this having function, right? This having function can help you to find the number of how many times and how many categories got repeated, how many times, right? So see the having function bit closer, you'll get to know better understanding. Select category for sure. Count of category for sure. Okay, I'll take a count as count from df. Group the category, segregate the category, having count greater than 1. Having count of category greater than 1. That means I am passing a function of having inside a aggregation. Select category, count of category. Okay, I'll take a count, but it's not a general count, right? As count from df, group by category, having count greater than 1. Having function will help you to perform, like it's almost like a performing a where operation along with group by. Visually, we have to write a subqueries. Then we have to write a subqueries. No, having will allow you to perform that filter here itself. Hey, take the category, take a count, everything is fine. Group by category, everything is fine. Take a count, but apply a filter here. Hey, having count greater than 1. It will perform and tell you, hey, these are the functions greater. Check here. See? That's what we call it as a having function. Now, folks, this is just a having function. Joins are going to be really, really important. Folks, joins are really is going to be very, very important, right? Now, to understand the joins well, all right, let's call out the other two data frames, right? These two data frames plays a big role in joins. Cust and prod. Check on this data. Yes. Now, take these two data frames, okay? Imagine these two data frames. This almost solves all the necessary problems. Have a check. TF1. Okay, this is cust and this is prod. Now, if you see the common column between these two, it's going to be the ID column. But for this ID, name I have in one table, product is there in the other table. Now I have to perform a join for these two data frames. Join in the sense, I need ID column and name column from the first table and product column from the second table. It's just like joining, folks. What does actually joining mean? Imagine I have a data frame and I have other data frame, right? But I'll have one common column between these two. With respective common column, I'll join these two data frames. That's what we call it as a joined table or data frame, right? Now, if you look out closer, we have a types of joins, right? Types of joins. What is actually the type of joins is? Imagine the requirement comes like that. How that comes, right? Take common IDs with name and product. What they're asking? They're asking the common IDs with all the name and product column. What are the common IDs we have? 1 I have, 3 I have. That's it. Only 2 columns I have with its respective product also. That's what the requirement is. This is what they're asking. For the common IDs, 1 and 3, between these two tables, they want the common tables. In the Venn diagram, imagine I have two tables, all right? I need the common IDs from both the tables, actually. This is what they're expecting. 1 and 3 are common IDs. Take the names and respective product for it. How to design an inner join? This we call it as an inner join. Inner join, right? Have a check. Spark.sql. See how the query runs. Select a dot star. From the left table, take the whole table, comma, b dot product. Imagine A is the left table, B is the right table. I'll give the aliasing shortly, right? From dfa join dfb. Have a check. Here I'm giving the aliasing. Select a dot start. Select all the columns. From second table, take product. From dfa join dfb. Here I'm giving the aliasing. Hey, df is A, df is B, df1 is B. On a.id is equal to b.id. Here I'm equating the IDs. Hey, in the A table, take the ID equal to b.id. Here I'm putting a proper join. This is an inner join result. Have a check. This is inner join. Select a dot star, select both the tables, both the columns, b dot products, one column. From df, join df1, where a dot id is equal to b dot id. I'm equating it. You will see the proper results coming up. Oh, sorry. Sorry. My bad. It is cust, right? Cust and product. My bad. Two tables, right? Not df or df1. Yeah. See, only intersected values are taken out. This is first type of join. I have documented it. Inner join. Now, left join. Now, let's take the same two table example, okay? Let's take the same two table example. Now comes a new requirement, right? Take complete left table and respective and its product from right table. That means ID, name, and product, same. They want the complete left table, no doubt about it. They need the complete left table, no doubt. No loss in the second left table. But from the right, take the respective product, right? And it's mobile. Only these two are matching. But all the other IDs becomes null because there is no product in the right table for that. Simple. What they're saying, hey, complete left table should be taken, but its respective table. There is no loss in the left table. That we call it as a left join. It will take the complete left table and its respective right table. If you see the Venn diagram for this, if I have the left table, it will take the intersection as well as the complete left table. Now, how to do that? It's quite simple. Same syntax, but change this join to left join. Simple. See, there is no problem in the left table, but we got something in the right table. That we got it here. Right? So this is the left join. Imagine I got another example, right? Now comes take complete right table, its name from left table. What they're asking? They're asking take all the IDs from the left table, from the right table, ID and product, and its respective names from the left table, and its respective name from the left table, like this. I have one. For 3, I have the name. For laptop, it is null. I do not have data in the left table. May ID, the columns might change. Columns might change. Name or ID product can be jumbled. That's okay. We call it as a right join. No loss in the right table. In the Venn diagram, data would be like this. Right table, no loss at all, and its respective common names from the right table. Change this to right join. Simple right join. Right join. Inner means just a join, left join, and right join. See? No loss at all, right? 1 and 3 it has picked up. I think 7 will also not come. One sec, one sec. 7 must come. Some issue in the data set. One sec. Let me check and get back. One sec. Folks, seems there is some issue with the data, but that's okay, right? But when I performed in DSL, it is coming perfect, but it should come. 7 should come. That's expected. I'll check on the null part because I may have to infer the schema once. Okay. I can infer the schema. Yeah. Let's see, or else we can move on. But DSL I performed just like SQL I performed in DSL. It is coming correct. It may do auto casting. Let's see. If this doesn't work, we'll move forward. No, that's okay. See, but this is expected result. Okay, just perform on that. In the document also, I'm going to put this screenshot, but I expected is 7. That should not come. Okay, that's right join. Now same requirement, but this time it's a different join. All right. We call it as a full join. Okay. We call this as a full join. Let me tell you what is a full join is, right? Fine. Now, what does this full join mean? Let me show you that, right? All the IDs from left table, all the IDs from right table with its name and product information, right? What is the expectation is take all the IDs from left table and its respective ID from the right table also. Now, no miss at all. All right. Now, I need all the IDs with all the names and product information, right? If I have product for 1, I need it for 1, right? This is a product. If I have for mobile, it's going to be mobile for 3. For 7, I have, that's okay. Put it laptop for 7. But I have to place null here, and null here. This is the full join. We call it as a full join. All the IDs, but I'm not sure whether this 7 will work again. That's okay. If that doesn't work, that's okay. But let's give it a try. Let's give it. This, this join, we call it as a full join. All the IDs will be fetched. All the IDs, right? We call it as a full join, right? Full join, right? Have a check. 7 is coming null, but suppose 7 should come. If this comes also, don't worry. There could be some data issue, but 7 must come. If that doesn't come as null, that's okay. But 7 must come. Maybe I'll check the data set. What's the issue? But it must come. If I perform in DSL, I think it's working. In SQL, I see that some autocasting is happening. That's okay. See, all the data 7 didn't come. That's okay. But ensure this is 7. 13572. All right. Wherever I don't see the data, that would be null. Okay. Uh, I can perform the same in DSL also. You'll see that in DSL, there is no problem will come. Facing only in SQL, right? I'll show that result. This is DSL output. I mean, it's Spark DSL. This is also full join. It is providing 7. The expected results also I'm showing you. This is actually expected output. 7 must come. I'll check why it is not doing auto casting. That's okay. But this 7 should come during the full join. All the IDs, no IDs are missed out. That we call it as full join. Right? Then another important join, anti-join. What is actually an anti-join? Right? Have a check. See, take IDs from left table which do not have in right table. Anti, try to understand. Comparing these two IDs, which IDs are not there? Comparing these two IDs, which IDs are not there in the left table? See, what I mean to say is, take IDs from left, which do not have it in the right table. 1 I have, 2 I do not have. No, take 2, because 2 do not have in the right table. We do not have 2 in the right table. Then 5. 5 we do not have it in the right table. Make sense? So I need this. We call it as an anti-join. Left anti, right? Left anti-join. Have a check. Left anti-join. What is left anti-join? We have these two. All right. Venn diagram. Left table, right table. I need to pick which does not match at all. No matching. Only 2 and 5 must come. One sec. Oh, okay. Product will not come, right? Because anti-join right table is nowhere considered actually. In the right, nowhere considered because obviously it would be null. So I'm performing it here. Anti-join. That's what I have documented here. Only 2 and 5 because that doesn't have in the right table. Now, this is what and joins are done, folks. Check the date format and subqueries. It's pretty straightforward. All right. So this is a kind of SQL I have done. Subquery is straightforward, folks. Date format is pretty straightforward. Or else let me execute the date format. All right. Now have a check. Concentrate on this date. In a simple words to say, imagine this is your date. I want this date in this format 2011 06/26. Like this I want. For this, I have to convert this into a Unix time. Then I want to change it to a from underscore Unix time. Right? Maybe I'm going to create one more video on this Unix time as well as explode, maybe shortly. That I'll cover up. But how this requirement comes, complete this in the first attempt, folks. The remaining things are pretty simple. Only date format is left. I'll create one more video as a short video. But however, till the joins, complete the basic ones. This completion, I'll show you shortly in another video. Thanks a lot. Complete this whole procedure first. Thanks for bearing with this. And I'll upload this video and let you know. Thanks a lot. I'm posting the document. Practice is everything.